Hello, amazing third grade math teachers. Welcome to the weekly preview for the week of October 24th. Okay, so this is a full week. Not used to those anymore, are we? So let's start off with what we're going to be teaching and the TEKS that go with it. So we're going to be teaching multiplication with arrays, using arrays with manipulatives and applying it to repeated addition. Remember, that goes with partly 3.4e, representing multiplication facts by using a variety of approaches such as repeated addition, which we've done, equal sized groups, which we've done, arrays, area models, equal jumps on a number line, which we've done, and skip counting. And so more specifically, 3.4d determine the total number of objects when equally sized groups of objects are combined or arranged in arrays up to 10 by 10. And so 3.4e and 3.4d can really kind of go together as far as the array part. And so it's been tested 2 times as 3.4d with arrays, and it's been tested 3 times as 3.4e, where sometimes there's an array in the picture. These also go with 3.4f, which is recalling facts up to multiplying up to 10 by 10 with automaticity and recalling corresponding division facts. Now, we're not going to worry about division this week. We're just going to worry about the multiplication piece. And remember that the verb in this TEK is recall facts. However, it's been tested 5 times, and guess what? Every single time it's been within the context of a word problem. So even though it says recall facts, it does not just ask what is 5 times 2. No, it's in a word problem. And so we need to keep having students visualize these word problems and using manipulatives and drawing and things like that in order to recall those multiplication facts. I've always been concerned about this TEK because it says up to 10 by 10. And sometimes on the STAR test, we'll have some 11 facts or some 12 facts or even some 13 facts on there. And so I was a little confused about how TA could get away with this, and come to find out, this is the answer. The up to 10 by 10 is only for the facts through the facts within 3.4f. It does not pertain to the other multiplication TEKs. So that's your answer on that. Sorry. And then 3.4k is also going to go with these TEKs as well, especially when we're talking about recalling the facts, 3.4f, because it is in context with a word problem. And then also our first day of the week, multiplication using arrays, because that's in a word problem as well. And remember that 3.4k, we talked about that last week, how it's been tested twice, where you have to multiply and then divide, which we're not there yet still, and then 4 times where you have to add first and then multiply. Okay? So Monday, we're going to talk about just using arrays and applying it to multiplication and repeated addition. On Tuesday, we're going to actually work on decomposing factors to multiply using arrays. And all that means is, you know those really hard math facts, the 8s and the 7s? We're going to break those down into other easier facts by decomposing our factors using arrays and showing students what that looks like conceptually. And then on Wednesday, we're going to multiply using the area model, but it still kind of looks like arrays, so it's not a big stretch in this part of what we're learning with the area model anyway, until we get to 2-digit by 1-digit. And then on Thursday and Friday, we're going to be focusing on that recall and using some strategy, looking at multiplication patterns, knowing that math is all about patterns and looking for those patterns in order to know our multiplication facts and learn them easier. And then Friday is tons of fun because we look at the multiplication chart, show students how to use that thing because they don't know. We kind of assume sometimes that they do, but they've never used one, so they don't know how to use one. And we're going to relate the commutative property to it, which they don't have to know what the name means, but just so that they know when they use a multiplication chart and they see 2 times 4 one way or 4 times 2, that the product is still the same. Whether it's 2 groups of 4 or 4 groups of 2, it's still going to be a product of 8. And so those are the things we're going to be working on for this week. All right, so let's start with 3.4D. Determine the total number of objects when equally sized groups of objects are combined or arranged in arrays up to 10 by 10. So in this question, the electrical panel shown has 4 outlets. And so we see 1, 2, 3, 4 outlets. How many outlets do 6 of these electrical panels have? And so what do you think might stump our students when looking at this problem? You guessed it. How many outlets do 6 of these electrical panels have? We're looking at this and they see, oh, there's an array and it looks like 2 by 2, so that's 4. Luckily, that's not even a choice, but they have to find out how many 6 of these outlets would have, right? Of these electrical panels would have. Okay, so that's one of the ways it's been tested. Now, this one's only been tested twice, so here's the other one. There are 6 photographs on each page of an album. 1 page of the album is shown. How many photographs are on 9 pages of the album? Now notice, this shows an array. It shows 2 rows with 3 columns each. So 2 groups of 3, right? Here's a group of 3, here's a group of 3. And that shows 6. And so obviously that's not a choice, but it looks really similar to the other way that 3.4D has been asked, doesn't it? They show 1 page or 1 electrical panel, and then they ask us for 9 pages and what that would look like. So, knowing that it's been tested this way, both times it's been tested, what do you think it will look like on STAR if it's tested? What do you think it will look like on the DCP? Hint, hint, if it's tested. Well, it's going to be tested on your DCP. I'm going to go ahead and give you that information right now. So you've seen it's been tested the same way twice. Both times it's been asked. It's been asked in the same way. So keep that in mind as you're teaching this in thoughts of your DCP and STAR later on. Okay, so let's look at 3.4E, which is very similar. This is that TEK that we've been working on, but we've worked on equal groups and we've worked on skip counting and number lines, right? Well, now we're just adding this piece of the TEK, which is the array. So this is the same thing we've already gone over. We've already kind of gone over this. Is a not question. This right here looks similar to repeated addition, but it's actually repeated multiplication. So that is absolutely not the same thing. And so, but we've already kind of talked about this, just knowing that we're adding this array piece. Okay, so how do we teach it? How do we teach the arrays? Well, first it starts off with that academic vocabulary. And I don't know about you guys, but for me, it really helps my students who are visual learners, of which I am one, to show some visuals. And so when we talk about arrays, we talk a lot about columns and rows. And so this visual really helps our visual students. It helps our English as second language learners, just helps all kinds of students. So when we talk about a column, we're talking about, like in this house or this mansion, a column is something that goes up and down, okay? and a row goes across like a row in a field. So hopefully that visual will help with that academic vocabulary of rows and columns. But how do we teach it? Of course, the very first day, we're going to start off with math and practice. And so we will start off with this very page, and we're going to teach this within the context of a word problem, which is going to be very helpful when we even get to 3.4F, the recall of facts. It's going to be helpful in our 3.4K 1 and 2 step problems. But it's also helpful for students to understand, like, what is happening, okay? So we're going to start off by posing the problem. There were 2 rows of tulips with 6 tulips in each row. How many tulips are there? So we're going to ask, what are we trying to find out? Is there a way that you can use a model to try to discover how many tulips there are? Now, some of the students are going to make equal groups because that's what we learned last week, right? And that's okay. What you're going to do is you're going to be looking to see, are there any students who actually build a model with 2 rows of 6 counters? And ask those questions. Hey, let's look on to a neighbor if they have 2 rows of 6 counters. What do you notice about each row? How many rows are there? Those kind of things. And so you're going to go through some questioning and modeling of some different situations within arrays, okay? And just to tell you a little bit more about math and practice, much of the time, there's a formative assessment piece towards the end of your lesson. This is a great place for you to check for understanding. Our new teachers just went through some learning on the lesson cycle. And guys, we don't want to send students off to independent practice before we make sure that they understand. So this is a quick check for understanding where you draw an array on the board or model an array on your document camera or in your Google Slides. And you have the students write a repeated addition equation and a multiplication equation that match the counters. So you'll notice sometimes in the math and practice book, you'll be like, wait, this is wrong. And sometimes it is. Sometimes you will see that down here, what the students write is actually incorrect, and that's okay. Usually it'll tell you right down here, like what happened, like this student got it right, and this student got it wrong, that kind of thing, and why. But it just kind of gives you some examples of what the students might put on that formative assessment. But there's no prep really for this, is there? Right? So easy, just a real quick check for understanding before you go on to the independent practice. So just a little shout out to Math and Practice, our amazing book as far as formative assessments goes. Notice this is done within a word problem, but what else do you see? Huge right here. It needs to be done with manipulatives. Anytime you're introducing something completely new to students, it needs to start off concretely first. It needs to start off with manipulatives first, then go to the drawing piece, and then go to where we can transfer it to a test question, okay? If you miss any one of those first 2 pieces, they won't be able to transfer it to a test question. They've got to have the manipulatives, and then they've got to be able to change that over to the drawing. Okay, so in your Google Slides that we create for you for every single lesson, you'll notice that, oh my goodness, there's a star question. Looks familiar, doesn't it? So sometimes what we'll do, and I think Nancy Crouch did this with you at Lead Forward at the beginning of the year for those of you that got to go, but what I'm going to do is tell the students, hey, I've already given you the answer. The answer's J. What I want you to do is use counters and explain how I got 54 to answer this problem. What did I do? How did I get J? And you'll notice that anytime it's a star question or very similar to a star question, I put this little star on the slides to help you know, hey, definitely don't skip over this question, right? Do you think that this will help on the DCP? I sure hope so. I hope that they don't just look at this and go 1, 2, 3, 4, 5, 6. Oh, the answer is 6. Well, the answer is 54. I've already told you that. So how in the world did I get 54? and I want you to use some counters to help you, okay? So that is how we're going to teach arrays. Now, the next lesson after arrays is how to decompose arrays to help you with multiplication facts that you don't know, okay? So for example, man, those 7 facts and those 8 facts are so hard, right? So the first thing we're going to do is we're going to create an array to show 8 groups of 7 using color tiles, or if you want to change that and do 2 color counters, really doesn't matter. But create an array. And what is an array? It's a rectangle made out of rows and columns. And we're going to create that array to show 8 groups of 7, okay? Or 7 groups of 8. If it's not a word problem and it doesn't matter the context, it really doesn't matter. And so we would show that. And once the students did that, and they might build it together in partners, that's totally fine. How many tiles did you use to show 8 times 7? Notice I'm interchanging that wording, 8 groups of 7, 8 times 7. I want to make sure and use both of those. How many tiles did we use? Well, we ended up using 56 tiles, but there's got to be an easier way, right? So we're going to show students how to split that up. We're going to decompose our facts because if you'll notice, this is 2 groups of 7. This is 6 groups of 7. 2 groups plus 6 groups gives us 8 groups of 7, right? So if I cut that rectangle in half and I split it in 2, I know my 2's. 2 times 7 is 14. I may not know my 6's, but I might know my 5's and then just add another 7 if I wanted to. But maybe I know my 6's. And so I know I'm going to have 14 plus 42, and I still get the answer of 56. That's one way. Can you think of another way you could split the array of 8 times 7 up into easier facts to help you know the answer of 8 times 7? Could you do 3 times 7 and 5 times 7? Ooh, I know my 5's, and I already know 7 times 3 because that's just one more 7 than 7 times 2. So I know 7 times 3 is 21. I just know that one. And 5 times 7, well, all I have to do is count 5 5's, and that gives me 35. And so 21 plus 35, all I have to do is add those, and adding's easy. So now my answer is 56. It might be a little bit easier than counting 8 groups of 7 or counting one by one, counting them all. Oh my goodness, that would be a little bit easier. So that's just a way to show students conceptually how to break up your factors in order to make an easier problem, okay? Because that's really what we want to teach students. Students aren't always going to know their 8's, right? But if they know their 5's and they know their 3's and we can put those together, then they really do know their 8's. So that's one way of knowing our facts. And we're teaching it conceptually with manipulatives. Oh, we're going to use a lot of manipulatives this week, aren't we? Which way was easier fact-wise for you? Totally depends on you, right? And the facts that you know. Okay, so now let's look at 3.4F. Every time it's been asked, which has been 5 times, it's a supporting standard, but it's been asked 5 times. Every time it's been asked in the form of a word problem, guys. So I can't just know 4 times 5. I have to read it in a word problem and look at this. 3 of those 4 times, one of them I think was a sample item. 3 of the 4 times that it's been tested, it's been a griddable. Oh my goodness, which means now that would be equation editor, right? Okay, so there are 4 erasers on each table in a classroom. Can you picture it? This is what we want you doing when you're teaching problem solving. Can you picture 4 erasers on each table in a classroom? There are 5 tables in the classroom. What is the total number of erasers on all the tables in the classroom? Could you picture your students making these groups with counters and counting them up? Absolutely. Could you then picture them drawing what they put with their manipulatives? This isn't real hard, is it? And pretty soon, hopefully, we can get them to count by fives 4 times. But first, we have to start at the conceptual, okay? And remember, this is going to be a griddable. This is going to be an equation editor. It's not really going to be a griddable because that's gone away, but it's going to be an equation editor. So let's have them typing these answers quite a bit too. Okay, so how do we teach it? Well, let's start off with learning the facts for recall. I'm so sorry, like the teacher says. But remember, math is all about patterns. So we're going to really look at patterns in order to help us recall these facts. But we're not going to forget that we need to use lots of word problems with manipulatives and or drawings because it's asked in a word problem in this TEK. So let's start with the twos. If you know your doubles facts, you know your twos. And so many of our students at least know their doubles facts. So if I know my doubles for 8 plus 8 is 16, then I know 2 times 8. And because of the commutative property, I also know 8 times 2. So that's 2 facts I already know, right? So we're going to teach our students those things about all of our 2 facts, okay? That's a pretty easy one, isn't it? Now, for your 9 facts, here's one trick that one of my students taught me one year that I have never forgotten.
Hi, this is Boston Parent Speaker. Sometimes learning your times tables can be difficult. Today we have a multiplication trick that can help you learn your 9's times tables. All you need is your 2 hands. So first you place your hands out in front of you. Your fingers will represent the numbers 1 through 10, 1 being your left pinky and 10 your right pinky. Let's say the question was 9 times 4. You will count your 4th finger stand from your left pinky. You will curl that finger down. Now your 3 fingers before the back finger and 6 fingers after. So the answer to 9 times 4 is 36. Let's say you have a number 5. We'll do 9 times 6. You will count to your 6th finger and curl that finger down. Now you have 5 fingers before your 4th finger and 4 fingers after. So the answer to 9 times 6 is 34. This hand trick works for all your 9's times tables, up to 9 times 10. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81, and 9 times 10 is 90. Hope you enjoyed this video.
Isn't that great? What a neat trick. And that is actually a trick, but such an easy way for students to really quickly know their 9 facts, right? But there's more than one way to look at this. This one I think is really valuable. So what you would do is write the 9 facts vertically and then have your students look at the products of the 9s through 9 times 10. Have them look at the 1s place and then the 10s and ask the question, what do you notice? And give them 1 minute to just look and think. And you may just start off scaffolding, say, just look at the 1s place first. What do you notice? Give them a minute to think. Your higher students are going to automatically, after they look at the 1s place, they're going to go look at the 10s place too. Okay, what do you notice? If I start here at 9 times 1 and I look at the 1s place, I'm going to notice 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then if I look at the 10s place and I start at the bottom, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Or I may look at it from the top again and go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's interesting. So then have them turn and talk. Like, what do you notice? You might even have some students that notice some other things. For example, every product of 9 adds up to 9. 9 plus 0 is 9. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. What? This is crazy. When you're looking at your 9s, 9 times 1 through 9 times 10, these are the patterns that we want our students noticing so that maybe they won't forget their 9s, because 9s could be hard if we didn't know a few of these things. So these are just simple, really quick things actually that we can teach our kids, but we need to let them discover them by giving them a minute or two to think, a minute or two to talk, and then come back together and see what all we noticed. And remember that math is all about patterns, and we're always going to be looking for those patterns anytime we're doing any kind of math. And so in your math and practice book, you have some different read-alouds that you can do for every one of these facts. And so the tens fact book is called Toasty Toes. And in your Google Slides, what we've done is we've put somebody reading the book on YouTube so that you can have it read if you don't have the book in your actual library. And so you can have them watch the video and fill in the toasty toes. So like maybe watch it once and then watch it again and fill in the chart and asking them, what do they notice? And hopefully they're going to come to the conclusion that whatever I multiply by 10 is that number with a 0 after it. Right? That's what we're wanting them to notice, so that our tens facts are super easy. Also, we can count by tens, absolutely. So lots of great things this week. 3.4K, of course, we're still looking at 1 and 2 step problems. Gerardo bought 3 packs of mint gum and 2 packages of bubble gum. Each package had 8 pieces of gum. How many pieces of gum did Gerardo buy? And guys, right here is a great time to have students using manipulatives or drawing pictures or both to solve that problem, right? And so this 3.4K is going to go a little bit along with arrays and a little bit along with area model and a little bit along with recalling our facts, right? So just keep in mind that we're going to keep using word problems, manipulatives, and drawings, and multiplication is actually going to be a piece of cake. Okay, so if you have any questions at all, my name is Sherry Height. I'm the math facilitator for grades 3 through 5, and you can reach me at slheight@mesquiteisd.org or call me anytime at extension 28705. Thanks, and I look forward to hearing from you again.